Has anyone ever heard of a mirage? Hopefully. Anyone know what causes mirages? Or is curious about this kind of stuff? A couple of years ago, I was driving with my son. I was taking him to summer camp, and we were driving on the Natchez Trace. It was in June. And he was sitting in the back seat, and he was looking at the road, and he noticed, yeah, it looks like there's water up on the pavement. Yet it was a sunny June day. And he was like, well, what's going on there? Why is that happening? And it made me very proud because it told me that, hey, he's observing the world around him, and he's curious about why things happen the way they happen. And that I love. That's still, that's a childhood curiosity. Children are full of questions because they're trying to learn about the world around them at a rapid rate. And there's so much new to them they've never seen before. And they look to authority figures for explanations. And so I love that I was part of his curiosity. And you know what I told him? I said, I don't know. Because at one time I was very convinced that I knew what caused mirages. But I've thought more about it in recent years, and I'm not quite convinced that the explanations that I had heard are correct. And for those of you who have been kind of following my lines of logic, this is an area that I'm really fascinated with. I'm really fascinated with why people believe what they believe, and what methods they've used to arrive at a belief, and whether those methods are reliable. And so what we see here is we see a palm tree, right? And what the illustration is trying to get us to realize is, yeah, we see in a mirage the palm tree, but it seems to be coming from the ground, right? And quite often it's inverted, right? The top of the palm tree we see at the bottom, and the base of the palm tree we see at the top of that mirage. The question is, well, what's going on? Well, I'm going to show you a video explanation. It's actually the author of the textbook that I used to teach from that I still draw a lot of these notes from, a guy named Paul Hewitt. And you've seen him before. Remember we talked about the cup and the index card? We did this demonstration before. Well, he's got another explanation for mirages. I'm going to share that with you and see what you think.
Atmospheric refraction accounts for mirages. Light travels a bit faster in hot air than in cooler air, so if the air near the ground is warmer than the air above, as it is in desert in the daytime, light from the palm tree refracts upward, which is to say, bends upward. Your eye interprets this as a reflection, when it is really refraction. Light from a distant blue sky that refracts upward in the same way gives the illusion of water not far ahead. Many a thirsty person wandering in the desert has mistakenly seen a cool pond ahead. Sorry, no refreshing drink. This is more common on roads where air warmed at the surface produces the same effect. Whenever we look downward and see sky, it's either reflection or refraction. Sometimes the two are confused.
All right. So he's essentially saying that it's, we think about mirages associated with deserts or hot days, hot summer days, like when I was driving with my son. And he says that it's that the heat, creates this superheated layer of air near the surface of the road or near the surface of the desert. And that superheated layer of air causes the light to bend, right? And again, that makes kind of physical sense to me. And for years, that made a lot of sense. Very much like the atmospheric pressure argument made me think that the car held in place, right? But then remember Aaron Freppen raised his hand and he asked a really good question. Well, what do you think about this explanation about mirages? About the hot air? Can you think of a situation where you've seen a mirage and hot air might not be involved? As it turns out, I have. In fact, there's a reason why I have this other link here. I like this. There's a website called Atmospheric Optics, and it's all about atmospheric optics, obviously. And there's a page on here which I like. I'm going to share that with you. And this is a picture from Murmansk, northern Russia. The temperature is minus 30 Celsius. And it looks like this is probably this is a morning shot. And yet we're seeing mirages. We're seeing the headlights from these cars coming from the roadway. That's a mirage. Is that light, where's that light coming from? And how is that happening? Minus 30 Celsius. My suspicion here is that there's not a superheated layer of air that's causing the light to bend. My thought on this, and I could be wrong, but is the real cause of mirages is that, and you saw this in the homework last night. Remember how once you got, when you had your light source at a certain angle, you would get refraction, the light would move through. But if you got past a certain angle, the light would not refract at all, it would reflect. That's something called the critical angle. That is a critical angle at which if light is coming in, a surface will behave more like a mirror than not, okay? So up to a certain amount of steepness, you're going to not get reflection. But once you get below a certain angle, you'll get light reflecting. And that's, I think, at the heart of what causes mirages, is that light is coming in at a low enough level that the surface, in this case, the roadway, is acting like a mirror. And therefore, we're seeing, in this case, headlights or sky or whatever. And again, what caused me to think about this was not only the atmospheric optics thing, but I see this at nighttime when I'm driving around at night. I see headlights from cars that are coming toward me coming out of the road, right? That's a mirage. So it makes me a little less confident that Paul Hewitt is right about the superheated air explanation. But it took me a long time to even be concerned about this, because it's something that I heard as a young child. I watched Bugs Bunny cartoons and they'd see mirages in the desert. I always associated mirages with hot air. And then I got these explanations from my physics classes about, oh, it's the refraction of light, it's bending of light just due to the superheated air. And only more recently when I've had to, and I've taught it this way, just like I taught this very confidently, semester after semester, that it was just atmospheric pressure, until I was caused to think again. And that's what I love. I love being less certain about things. And I think that we're in a time period, and it's always been the case, where human beings, we naturally like to be certain. We like to have a high confidence. We like to believe things. We'd rather believe something. We'd like to have a reason for something rather than not be sure. And I think it's a weird thing about the human mind and psychology. But I've found that the more you're open to being uncertain, the more likely you are to get to the truth of things. And so I'm not quite as confident in Paul Hewitt's explanation anymore. I think that reflection might be a better explanation. And another part of my reason for my confidence is on a sunny day, such as when I was driving with my son, we got a mirage from the road surface, but just off the side, the shoulder, which was probably just as hot, the air was probably I wasn't getting a mirage. And that's because the shoulder is full of gravel, right? And not as smooth of a surface as the actual pavement. Less likely to act like a mirror, even with light coming in at a low angle. So anyway, this stuff may not interest anybody but me, but it's real. It's around us all the time. And it's very easy to just accept the explanation, especially if someone in authority, teacher, preacher, coach, whatever. We should always be questioning, especially the things we're most certain of.